All right, this is Advent of Code 2020, day 11. What do we got? Seating system. Seating rules until notice how many seats end up occupied. Okay. There's a grid, empty, floor, or occupied. Let's see. It's empty and there's no seats, no occupied. It becomes occupied. Okay. Adjacent means needed for -101. Becomes what? Empty? Sure. Seems reasonable, but it's wrong. So many wrong answers. 7. Okay. Adjacent, they care about the first seat in each of the 8 directions. Not empty, but just the first seat, huh? Okay. 5 and 26. Is that the right answer for this sample? Yes. Okay. As usual, it seems like kind of a weaker part 1 and a pretty good part 2. Okay, so what was going on here? So we had this import grid, and we were supposed to apply these rules, almost like a cellular automaton, like Game of Life, if you've heard of that. Right, so in this case, the rules are basically L's sometimes toggle to hash marks, and hash marks sometimes toggle back to L's, and dots always stay put. So if you're an L and there's no hash marks around you, you change into a hash mark, and if you are a hash mark and there are at least 4 other hash marks around you, then you change into an L. Right, so if everyone's empty, everyone becomes a hash mark because there's no occupied, but then a bunch of the hash marks turn back into L's because they're too crowded, right? There's 4 more around them. And anyway, the point is eventually they claim it's going to stabilize. I'm not sure if that's always true. Probably it's just a property of the input. And the question is how many hash marks are there once it stabilizes? Relatively straightforward. You just sort of run the rules. I guess the bug that I had was that, of course, you should sort of compute this for every square simultaneously. I was like doing updates and then using the updated squares in the neighbor calculation, but that's wrong, right? You should just use, right, like here, you don't change them to hash marks 1 by 1 and then figure out what, right, the fact that this guy becomes a hash mark does not mean that this guy can't become a hash mark, is what I'm trying to say. So that was my bug for part 1. Kind of a mess to like do parts 1 and 2 in the same program. Oh, also I didn't strip out new lines. That was another bug. Yeah, so eventually it'll stabilize, and then you just count how many hash marks there are. And part 2 is pretty much the same thing, except they changed one of the rules from 4 to 5. And also, basically, when you're looking in a direction, you skip over floor tiles. Instead of just looking, 1 tile in each of the 8 directions, you look as many tiles as you can see over floor, basically. Only skip for in part 2. those are the two changes between the parts. So that should do it. So we print 2359 and 2131, which is right. Okay, good. So this code is fine. Right. So the code for the two parts is actually very similar. So I've encapsulated it in a single function, and there's only two changes between the parts. One change is that you only skip flow tiles in part 2. So this is how I'm skipping flow tiles. Right. So compute the 8 different directions. Right. This is the staying still direction, which is not a real direction, so we skip it. Maybe a clear way to write this actually is if br is 0 and bc is 0, then we continue. And then we can unindent all this stuff. So anyway, take a step in that direction, and then in part 2, while you're in bounds, this is important for grids, and while you're on a floor tile, then keep stepping in that direction. And then once you've reached an actual seat, or in part 1 you've just taken one step, if you are in bounds and you are on a hash mark, then count it, right, as an occupied. And then just apply the rules. And in part 1, this threshold is 4, and in part 2, this threshold is 5, so fine. And those are actually the only changes between the parts. Right, so just to handle this case of sort of applying the updates simultaneously, we won't modify L at all. We'll just keep track of a new, we'll just make a new copy of the grid every iteration. And then just assign it to the new copy at the end. And also, we need to keep track of if we found a change in this iteration, right? So just when you actually change something, mark down change equals true. And if you didn't find a change, then you're done, right? So you just keep running this loop until there's no change. And then you just count the number of hash marks in the grid. So that is it for day 11.